Hello! So, today's video, we're going to be talking about motion in space, and particularly talking about how to define velocity and acceleration. These should be pretty straightforward. Acceleration does have a little bit access to it, which is going to be a lot more useful for engineering majors and physics majors. For some of the other you, it might not seem as interesting, but there's still some applications in here that can figure in with what you have already done. So let's take a look. So first of all, velocity and acceleration. So quite often we have a case where we're given the position of a particle in a vector function notation, which usually that's going to be denoted as r of t. Well, to get the velocity, as I've already stated before, you can just take the derivative piecewise, and that works fine, and that'll give you the velocity of your particle in motion. Now, some basic notation, when we're talking about bolded v, that's the velocity vector. So that's the direction the velocity is going and the magnitude. Whereas just the soft v of t, let's just talk about the magnitude of the velocity. So similarly, the acceleration, you just take another derivative. And again, it works the same type of situation. And then again, we can use the notation normal a is talking about just the acceleration, the magnitude of it. The bolded a is talking about the vector of your acceleration. So there's not too much going on there. Now, what's slightly different about talking about acceleration of a particle as opposed to talking about it in just 2 dimensions is when we're talking about the normal and tangent acceleration. Because usually when we're talking about acceleration, it's just straightforward, not going anywhere else. But if it's a particle that's moving around and turning around in space, it's going to have acceleration going in multiple directions. And if you're building something that's designed to travel in different directions, you have to keep in mind the acceleration that's happening in either direction, so to make sure that the structure can actually hold up to whatever forces it's being subjected to. So there's actually a fairly interesting formula for this one, and this is how you end up setting it up. So your acceleration, the vector of it, can be given by this formula, where you have your derivative of your magnitude of your velocity multiplied by your tangent vector, and then you have the curvature and the square of your velocity magnitude multiplied by your normal vector. So this gives you the 2 different aspects of your acceleration. Now, to find out what t is, you take your velocity function in the vector notation and divide it by its magnitude. So you're basically just making a unit tangent vector. Now, to get it to your normal vector, you have to take the derivative of that and then do essentially the same thing where you're taking a vector and dividing it by its magnitude, turning into just your unit vector. So those are the 2 interesting aspects of dealing with a normal and tangent for your acceleration of your particle. So hopefully this has been helpful for you. See you in class.